Here's the third and final example from 2.8 day 2. We're again going to use a sign chart. We're going to go through the same overall problem solving process, but we start off with something a little bit different. You might look at this and say, oh, this looks a little simpler than example 2. That doesn't seem like it'll be much trouble. But the problem here is that we have minus. We're used to having all multiplication in these types of problems. We need to have all multiplication or just fractions in order for this to actually work. So before we can even do anything with that, we do have to convert this into a slightly different form. And you'll notice this one's a fraction, this one isn't. We want to subtract fractions, which is the same as adding fractions, which means that we're going to need a common denominator. So thinking about the denominator here of x, if we want to add that to x squared, remember that x squared could be represented as x squared over 1. And then we would need to multiply both top and bottom by x in order to combine it with this so we have common denominators. So that means now we're going to have x cubed over x minus 2 over x greater than or equal to 0. And then we can combine that into one full expression by just taking the numerator, combining that, and then the denominator stays as x greater than or equal to 0. Once we have this, now we're talking about a form that we can deal with to put it into a sign chart. So we go to the sign chart as showing our work again. Now, by the way, you guys, this is going to be a problem very similar to number 48 in your assignment. So take a look at this one when you're doing 48. We write our number line. And we got to find either zeros or undefined values. This one's a little tricky as far as the zeros go. But this one here that one's going to be just 0. But then this x cubed minus 2, how does that equal to 0? The nice thing is we can do a little mini equation. X cubed minus 2, I want to find out where that's equal to 0. And so add the 2, x cubed equals 2, and then take the cube root of both sides, meaning that x is equal to the cube root of 2. Now, since it's a cube root rather than a square root, we don't have to worry about plus and minus here. It's just cube root of 2. Now, you might be wondering, well, what is cube root of 2? The calculator can do cube roots for us. So just a reminder of where that is. If you go to math and down to number 4, there's cube root. So that's cube root of 2. So we got approximately 1.26. We'll keep that in mind as we're graphing this, as we're walking through this. So x is approximately 1.26, but we'll just use the value on the number line as cube root of 2 just to keep it exact. So we're going to label these on here. We got 0 and we've got cube root of 2. The 0 is actually an undefined value because, again, it was on the bottom. This one is a 0. So now we have to do our test points as before. So we do our test points and we start with, well, let's say -1. If we do -1 cubed minus 2, so -1 cubed is -1 minus 2, that's going to be a negative on top, and then negative on the bottom. So that means that this interval, negative divided by negative, is a positive. Okay. Then we do, let's say, +1, so because that's somewhere in between 0 and 1.26. That's why I wanted to know what that value was. So I pick 1. 1 cubed is 1, minus 2 is -1. So that's negative I can put on top. On the bottom, +1, so that's positive. And that means overall that this interval is negative. One more to go. You're probably guessing what this one's going to be because most of them to the right are positive. But if we choose something bigger than 1.26, that might be 2. And so we do 2 cubed is 8 minus 2. That's positive on the top. And then 2 on the bottom, that is positive. And so then overall, our interval is positive. All right, so now that we have this all labeled out, we need to solve it. That's the whole point, is solving this thing. And so you'll see here is that we've got a couple of positive intervals. It is greater than or equal to, so we do want the 0 here. We're going to have on this spot, we want this to be a square bracket and go up from here. And then over here it's positive also, and it's going to go up to this one. Now that's going to be rounded because this is undefined. And so the last thing we might do is look at this graph and chart out the solution. So the graph here that we have, as you might be able to tell, has a vertical asymptote there. Here's where we have the cube root of 2, so it is going positive there, it's positive up here, but our solution, maybe I covered up a little bit of it right there, but our solution now, as you might be able to see, is negative infinity to 0 and square bracket cube root of 2 to infinity. So the details are very important. The little picky details can make a difference. But the square bracket here is, again, because this was a greater than or equal to. And then we have our final solution. That's everything included.